Okay, let's bring it in, kids. So far, a few things. What'd you think? It was pretty good. I mean, the poll results, you guys were pretty happy. Some of it was rough. It was better. Some of it was hard. It was better than yesterday. Yesterday's homework. It was better than 2 nights ago. Yeah. Okay, that's good. Let's do this. I like the shouting method. It's kind of fun. Think of the number you want to talk about first, and just shout it out on the count of 3. 1, 2, 3.
48.
Ooh, whoa. It's amazing how you and the other class, you're just in sync. Number 48. Number 48 is a fantastic question. Do you understand the shape? Do you understand what it's asking you? You have this nice, Norman window, I think it's called? This great window, and all they tell you is that the base is x. That's it. And what do they tell you about the shape up top? It's a half circle. So write down what they tell you. That's step 1. Write down what they tell you. What's one thing about this? What else do they tell you? Perimeter equals what? 30. 30 feet, I think. Okay, that's nice. What do you want to find? Area in terms of what? So you want a of x to equal something, and it's just in terms of? Just in terms of x. There are 2 shapes that add together to get this area. What are the 2 shapes? And a rectangle. Half circle and a rectangle. Well, do we know how tall this rectangle is? Let's say L. Is L okay? So what's the area here? L times x, x times L, right? Well, we know, let's use some nomenclature here. Let's call that A, B, C, and D. We know the distance from A to B is x. What else do we know is x? C to D. So, if we want the area of a half circle, what's the area of a half circle? 1/2 pi r squared. In this case, what is r? Yeah, x over 2. So in this case, the area is 1/2 pi x over 2 squared. So the area of the top, this is the half circle. What's that area? If you multiply it out. X what? X over 8 pi. And we know the area here is Lx. So what's the, right now, what's the whole area? Plus XL. I like writing XL better. That's fine. Sean, here. Thank you. What's the problem here, though? Does this answer the question like it wants to be answered? No. This is the problem. We want L in terms of X. What fact have we not used yet? 30. We haven't used the perimeter yet. Well, let's think about the perimeter here. We have X right there, and then we have how many L's? So we know that the perimeter is going to be X plus 2L. And now we need to know what's the arc length from C to D. So you have C to D. You know, that's a bad arc. You know, C to D is X. If you want, it's half of a circumference. The circumference of a circle is pi times what? Diameter. So 1/2 the circumference is pi over 2 times D. Hold on. There's a lot of different ways to do this. Just go with me on this. So we want 1/2 the diameter here. What is the diameter? So from here to here is going to be 1/2 what? Pi times x. So what do we now know? So it's plus what? Plus pi x over 2. So we know the perimeter is x plus 2L plus pi x over 2. But what is the perimeter? It tells us. What is it? So we know that 30 is equal to x plus 2L plus pi x over 2. We now have a relationship between x and L. We want to make L in terms of x, so what should we isolate? L. 30 minus x minus pi x over 2 is equal to 2L. Divide by 2, and what do you get? L is equal to 15 minus. So now, do we have L in terms of x? Yeah. Now what do we do with this? Substitute in, which gives us the area in terms of x is x squared over 8 pi plus x times what?
15.
How many people have done problems kind of like this before? You have to substitute in. Yeah. This is the area entirely in terms of x. It's entirely in terms of x. Is this a linear function? Is this a linear function? Oh, come on. Is it a linear function? Can you speak so that humans can hear you?
No.
No, it's not. Why not? There's an x squared. What type of function is this? It's a quadratic. So this is definitely a quadratic. How many x squareds do you see? Give you a hint. It's not 1. It's not 2. It's not 3. Actually, it's 3. You have your x squared there, and then you have one that gets created with x times x over 2, and you get x times that one, right? So you have a quadratic. This is slightly trickier. Does this quadratic face up or down? It's a little hard to say. Why? A parabola faces up if what? If A is positive. It faces down if A is... So, if this faces up or down depends on the what value? The A value. Is the A value totally clear here? You need to do some work to find the A value. Go to lunch and we'll talk about this at length when you get back. We now have a function for area in terms of x. What might be something that's nice to find out? If you're building this window, what? Does it go up or down, right? Does it open up or down? So in order to answer that question, I want you to graph this function. Graph it for me. Make sure you choose an appropriate with an appropriate window. Please do that right now. Graph it with an appropriate window. Faces what?
Down.
Down. There you go. It does face down. You should end up with a graph that looks something like this. How many people ended up with a parabola, something like that? This is the area, and this is the x value. So it's the width of the base and the area. That's not a very good parabola. Let's draw a nicer one. What point are you? What's one point you're pretty interested in finding on this graph? The vertex? Well, we know it goes through 0, 0. That's true. The vertex might be fun to find. Why is the vertex, in terms of this problem, why would the vertex be an interesting point to know? Nope, it's not the greatest width. This is the area, and this is the x value. So what can that tell you if you found the vertex? The maximum of the area, exactly. So this is x, f of x. That's the area. So the vertex is what? Represents, what can you find there? The location of the max area. So when you graphed it, you probably, let's see if I still have this up, something like this. Who has something like, I think that's about what it is. How do you go about finding, you have to use your calculator because you haven't taken calculus. How do you go about finding the vertex using your calculator? Someone raise their hand and tell me what I need to do. Tell me, what do I do? Yep. Yep. So calc, and you go to? Yeah, and then it asks you for left bound, so you go definitely to the left of it, and then you go definitely to the right bound. And then it asks you for a guess. So you do the guess here, and you end up with that. Oh, that's nice. Oh, look, I already took the screenshot of that. So there it is. So what do these numbers say? What does this represent? What is that? The max area. And this is the width that results in the max area. Okay, so if the width is 8.401, if that's the width, what's this window going to look like? What do you think? At the maximum area, do you think it'll have sides on it still? What do you think? Well, it's not a square. This function, as x, it starts like this, and then it gets wider, right? Keeps on getting wider. So somewhere in between, the area is going to be maximized. Now, do you understand what I mean there? It's getting flatter. Okay. There's some blank stares. I wasn't sure. Now, you brought up another point that would be interesting. So we know it goes through 0, 0, and we just found the vertex. What's another point that would be good to find? The X Intercept. Now, if we go back to our calculator, if I wanted to find the X Intercept using your calculator, what function do I use on trace right here? Look up at the screen. What is it? 0. You're finding the 0. Intersect is used to find the intersection between two functions. So you have 0 built into this thing. So it asks you for a left bound. Press enter. And then it asks you for a right bound. So go below it. Press enter. And then go back. And press enter. Now we just got that 0. That number should look familiar though. We just got that 0. So there's a relationship between this number and a number that's on the board right now. Of course, because what can you tell me about the symmetry of a parabola? It's symmetric over the x equals whatever that vertex value is, the x value of the vertex. So if we're at the same y value, which is, in this case, it's 0, this is going to be 2 times the x coordinate of the vertex. In this case, it's right. That's the number right there. Here's something interesting to consider, though. So this tells you that when x is 16.803, what's the area? The area equals that. Here's something interesting to think about, though. When we came up here, here's our function for L. That's the height of that. That's the side of the windows. You remember what L represents? The side of the windows up here. The L values. Well, let's look at this. What happens when x is 16.803? I'm going to show you something on your calculator. I entered. You see this right here? What is this? 15 minus x over 2 minus pi x. What is that? That's function for L. That's the function for L. What I'm going to do, I'm going to select y2, parenthesis. I'm showing you this, and I'll show you where the buttons are in a minute. But what's the number? 16 point what? What I'm doing is I'm trying to find what is L when x is 16. We just found out that the area is 0 when the base is 16. So what's the L value? What's the problem? There's no area, and the L value came out to be negative. L less than 0, is that allowed? No. No negative lengths. So the question is this, everybody. The question is this. Can x actually be 16.802? No. If I just asked you, let's look at this function right here, a of x. Let's just say I didn't put this in the context of a problem. I just gave you this. If I just wrote this function down, what is the domain of this function? What numbers are you allowed to plug in? Wait, no, hold on. If I just gave you this right here, if I just said, what's the domain of this function? All real numbers. Why is it all real numbers? What are the two things you're not supposed to do? You're right, anything could work. What are the two things you're not supposed to do? There's no dividing by 0, and there's no... As long as it's an even root. Are there any roots in there? Any dividing by 0 dividing by a variable x? No, so it's all real numbers. So this is the domain. The better question, though, is what is the effective domain? Meaning, what is the... You can think of it as real life domain. Well, we know that x has to be, on this question, area. What can you tell me about area? Area always has to be... You know that area has to be greater than 0. What do we know? For the area to be greater than 0, it has to be greater than 0. X has to be greater than 0, and it has to be less than 803, right? But when we plugged in x into that L function, what happened? What happened to L? It came out negative. Well, A has to be greater than 0, so does L has to be greater than 0. So the question is, for L to be greater than 0, what does x need to be? For L to be greater than 0, what does x need to be? And do we have a function for L?
Yeah,
we have a relationship here. Where is this? Right there it is. What type of function is that? Anybody know? Here's our function. We know L has to be greater than 0. What type of function is this? Is it a quadratic? So what is it? It's a linear function. What do we need to isolate? Well, we want L to be greater than 0. If we want to know where L is greater than 0, what do we need to solve? We need to know when the function is... When it's what? Is 0. We need to know when it is 0. So we make 15 minus x over 2 minus pi x over 4 equal to... Now we need to solve for... Let's take these and put them on the other side. And you end up with 15 equals x over 2 plus pi x over 4. What's the best thing to do at this point? Someone raise their hand and tell me what they think the best thing to do is.
Multiply by 2?
Sure. Now what? Multiply by 2 again. I really like getting rid of fractions. That's perfect. Now what? What's the best thing I can do at this point? Shock. Thank you. Love it when kids see the factoring without me having to push them to the edge. And now, what is x equal? 60 over. If we go back to here, 60 divided by 2 plus pi. What do you end up with? Ooh. Is that within reality? Yeah, it's within reality. So let's check this out here. Well, it likes to insert it for some reason, and it won't let me move it. So it's there. Okay. It really wants to be there. So that, what does that say? When that's an x value. So when x is that value, what is L? 0. Let's see if this works. If L is 0, you end up with a shape that looks like this, because there's no sides. This is 11.669. What should the perimeter be? It should still be 30. If our rules hold, it should be 30. If it doesn't come out to 30, what does that mean about our math? We did something wrong. How do we figure out that half arc? It's going to be 1/2 pi times, 11.669. Can someone take their calculator and do that for me? And tell me what you get to 3 decimal places? 18 point what? Well, look at this. 11.669 plus 18.329. I think that's equal to 29.998. Can you check that for me? I think it is. We might have done the same thing last class. Is that exactly what it should be? Yeah, I mean, we rounded here, and we rounded on this one as well. So is it okay it's off by 0.02? Yeah, it should be 30. So does this make us happy? Yep, it does. This does check out. So the rules still hold. So what is the effective domain? Is x less than that? Well, no, because can x be 16.803? No, because if it is, we know that the L is negative. So how do we keep L positive? Well, L is going to be, has to be less than 11.69. So overall, this right here, this is the effective domain. In reality, X can't be greater than 11.669 because if it is, the L value becomes negative. And then if you go even further to 17, what happens to the area? If X is 17, what happens to the area? No, it just becomes negative. It becomes negative. We know that A stays positive as long as X is between those values. So what happens if you go outside of that? A becomes negative. So when you're thinking of effective domain, you have to think of all the reality. Area has to be positive. Length has to be, generally speaking, time needs to be, generally speaking. Unless you're playing cool video games like Braid, but, you know. Please put everything away except a pencil and a calculator. Take care of calculators. What's coming up? Whose parents are coming to parents' night? Get a few. Send them. I have to be here, so it's nice if I have someone to talk to. It'd be great. You will have, so the big thing that's coming up is your Unit 1 test. Your Unit 1 test will be on Monday. Tuesday's a good day. Tuesday is a good day too. Monday's better though. Oh yeah, we like to do that. Yeah, we conspire. Go do stuff.
Yeah,
Go do stuff.
My teacher was like, yeah, go have fun. Enjoy your afternoon. Here's some homework.
Yeah, we think homework's fun. Oh, there's the logic. At this point, we've seen all of the topics that will be on the Unit 1 test. So what we're going to be doing on Thursday, tomorrow, and Friday is preparing for the test. Does that sound exciting? It sounds really exciting? I think it sounds pretty exciting. In this packet right here, your homework is going to be, we picked some good ones. So it's from this packet, the second one. The packet is also up in digital form in the homework folder, in the class folder, so if you ever don't have it and you need it. So these are the questions you're going to be working on. So what I'd like to do at this point is open the floor to any specific questions that you have about Unit 1. Any specific questions that you have about Unit 1. We have time for a couple questions. Yes? Yes, an increasing and decreasing problem. So for example, if I gave you something that looked like this, and I asked you where is this function increasing, where is f of x increasing and where is it decreasing, if I asked you where it is, you can answer in different ways, but what points are you going to have to find? Yeah, the proper way to say that, and this is a calculus term, is the local minimum and local maximum, meaning in this neighborhood, in there, what's the maximum? Something around there. In this neighborhood, what's the minimum? Here. If you expand that, are those overall, are those absolute minimums and maximums? No. Does this function have an absolute minimum? Does it have an absolute maximum? No, because it goes infinitely up and infinitely down. There's no absolute extrema is what it's called. So these are called local extrema. This is a local max and a local min. So you need to find those points. In general, everybody, if you have to do this, it's probably not going to be a nice answer. You need to round to 3 decimal places. Why did I choose 3? Does anybody know why? On the AP, sorry, what's your answer? It's safer. It's not too long. It's not too short. It's also the number of decimals you're required to put down on the AP Calculus test. You have to put down 3. It's wrong if you don't put down 3. So let's say this point right here was, I'm going to make up values here, 3.029, 4.628, and that point right there is 6.092, 2.456. Can someone tell me where is this function increasing? Where is it increasing? Raise your hand. Yeah.
It's increasing from infinity to 3.029.
Yep, okay.
And then from 6.092 to
I wrote this. There's something wrong. What's wrong? There's something wrong with the notation right there on both of those. Anybody know what it is? The numbers are correct. The notation is wrong. Something's wrong with the parentheses. Which one's wrong? Yeah. Yeah, these, they have to be open. Is the function increasing at 3.029? No. Is it increasing at 6.092? So it's not increasing from that. It's increasing infinitely close to it, but not at it. So you can either write it like this or be very specific. You would say it's increasing for every value greater than 3.092 and for every value less than 3.029. It can't, at 3.029 and 6.092, is it increasing or decreasing? No. So where is this decreasing? 3.029, infinitely close to 92. Are these points? No. No. These are, I know it's dangerous kind of writing these two close together. This is a point, and this is a point. It should be very clear if it's a point or part of the domain. You can also write it like this. What's another way to write this? X is less than. That's great. That's perfect. And X is greater than 6.092. And this one is X is between. X between. Yeah. Does that answer your question? Okay. Other specifics that people want to talk about. Anything else? So you had four ways to talk about a function: domain and range, symmetry, piecewise functions, and increasing, decreasing.
Can we use the one that you have to find the equation from the linear graph?
That's a great thing to do. That's a great thing to do. I'm not going to ask you any. I'll just tell you this. When you have to go from a graph to functions, I'll just tell you this. The three types of function, there's only two really. You'll either have linear function or a quadratic. And a type of linear would be absolute value. But you don't always have to use absolute values. My point being, the pieces, I'm not going to give you a trig function. Well, that's not true. I might give you a trig function.
Can you use the like up to home?
Yeah, sure.